good to go.
Excellent. Thanks, guys. So, brief introduction. This is a presentation I put together and gave at a recent conference, which talks a little bit about some of the problems and experiences we've had with some of our clients here at Coveros. And I want to talk a little bit about how we were able to kind of help our clients move forward through some interesting challenges. And one of the things to really highlight that I'd like to put through in this talk is how you don't have to be perfect and you don't have to do everything perfectly to see some real benefits by putting things like continuous integration and continuous development, or continuous delivery into the world. Like, how do we embrace some of these DevOps principles that we're seeing and talking about to get somewhere positive, even if you are not in a perfect world. So with that, everybody here at Coveros, I hope, knows who I am, but I'm a software engineer, and my whole perspective on how I come at these things is I'm a software engineer that's turned into a DevOps guy, right? So I spend a lot of my time automating the build and delivery process for our customers, and that's really where a lot of this context comes from. And I'm going to talk very specifically about some of the customers that we've been through. I work for Coveros and have worked for Coveros and in similar organizations pretty much throughout my entire career over the last 25 years. So I wanted to talk a little bit about that today. But specifically, I want to tell everybody, both within Coveros here as well as anybody else who ever might listen to this, about some of the successes we've had by applying what I will call DevOps engineering principles to improve how we do continuous integration and continuous delivery for some of my clients. And some of these are troubled clients that have started in hard places and fixed a lot of stuff. Some of them start in different places. Just as a note, whenever possible, I edit these stories for comic effect and try to be as lighthearted as possible about it. The reality is we always start somewhere, and we want to get somewhere better. So when I talk about DevOps or even CI/CD, there's always kind of a goal state that we have in mind, or certainly I have in mind, of where we're trying to get. And a lot of this has to do with introducing things like CI/CD capabilities, right? This is continuous integration. How do we do this kind of stuff on the left of this diagram, where a development team is committing code, they're going through build cycles, they're doing test automation, they're checking and making sure that their code is good, so that as you move right across this diagram up here, you start getting higher and higher confidence that what you're putting together is good, right? And that eventually leads to what we talk about a lot of continuous delivery automation, where we have some mechanism to take our newly built software and deploy it into an environment so that we can actually run it and do real testing on it, right? And this is where maybe a QA group gets involved, right? In many places now, we're talking about doing cloud-based deployments, which is we don't just want to deploy on a set of physical machines, we want to push it out into the cloud, whatever we mean by that, right? And everybody means something differently. But a lot of it is integrating test and security automation into the process so that we're getting these checkpoints. So again, as we move right across this diagram and start moving towards production, we're integrating all these different teams that need to assess and complete things and get a good understanding so that we have confidence that by the time we get to a production-like environment, we have good, highly secure software, right? And a lot of times what we want to do is use things like quality gates and dashboards to get a good feeling for where we are with our software, right? The way that we do this, and a big kind of push for how we do things at Coveros here, is that we want to apply these DevOps engineering practices, right? So this means things like incrementally building your capability, right? You don't have to have a perfect world to start applying some ideas of DevOps and getting some of this automation in place. Start somewhere and grow organically, right? We want to make sure we're treating everything as code, and I'm going to explain what all this means, right? We want to check things into version control and keep control of them and know what's changing. We want to DevOps our own DevOps process, right? As we build these things out, we want to make sure that we have a way to automate what we're doing, automate our ability to test our own code, because all of this DevOps and automation, quite frankly, is more code. We need that. We need to realize that usability of this entire system in this pipeline becomes key. How do the right people see what they need? How do they do what they need to do when you're talking about very disparate groups in some cases, right? And then finally, we talk about shifting assurance activities as far to the left as we can. And many times this means emphasizing those feedback loops. We see many feedback loops in this diagram. And we want to make sure we're getting those, right? So this is the goal state. No matter where we start, this is kind of what we think of that we want to try to get to. So what we typically find is that, that's the target, but we don't always start where we want to be, right? So our typical starting place may be all over the map. Everybody's got a different way of doing things. Everybody's got a unique set of problems. So we really want to try to capture that and see how to go forward. Well, certainly on a recent project, and maybe a couple of them, there are absolutely some horror stories of like, oh my God, where did we start? And all of these have probably good kind of how they got there type stories behind them. But I'll use some of my current projects as an example. In a current project, one of the things that happens is in order for app dev to hand off what they're doing onto a QA or a deployment organization, they fill out this horrible multi-page, what they call build request form, which is this giant spreadsheet with a bunch of fields in it and what's changed and all this crazy stuff and requests of what to do, right? So this manual, nasty little document that gets created and sent off. And quite frankly, all the app dev teams, all the ops teams, and all the QA teams hate this document, but they haven't figured out how to get rid of it, or at least they hadn't until we started progressing with things, right? That's where they started with. The quality and the build engineers had to hop through somewhere between 3 and 5 different VPN connections and get on as many as 6 different Jenkins servers just to produce a single deployed build, right? So it was this huge hop around, go crazy type problem where they had to do it, right? The deployment engineers themselves executed multiple what I would call command line custom built shell scripts that basically unpacked a bunch of zip files and pushed them out to hundreds of servers. Good news, it was kind of automated. Bad news is it was hugely error prone and it caused all kinds of problems. A typical deployment for these people, the first one I ever sat on when I observed this project was a 12-hour, 14-person online distributed Skype call, which by the way was on a Saturday, right? And it was like the most painful thing ever because you never knew what was going on or who was doing what. And then finally, like they constantly had resource problems because the build servers themselves weren't set up to be scalable and they were constantly over capacity, right? So this is kind of the state of affairs when I came into things a while back. And in looking at it, my first reaction to this was, oh my God, we just need to fire everyone, write a bunch of scripts, and go home and make this work, right? And granted, that was a slight overreaction, but it was just like, wow, this is truly painful, and it was painful for everybody. And kind of, what that looked like graphically is, you had all these little pictures of Jenkins, right? I had 6 different Jenkins servers all over the place. And by the way, none of them were connected to each other, so they couldn't talk, right? So the kind of top left corner up here is where the original, was where one build server was. And this was the one, by the way, that, could compile and do unit tests and sonar, right? And that was over on the development VPN, and that's where developers could go and look at what their code was, right? And then that would run like, I don't know, hourly or daily to do some of this analysis, so it was not very up to date. But that's where the developers lived. Then they would fill out this crazy build requests, and somebody would run it over to the build and deploy team, right? And those guys would go on a completely different Jenkins server and recompile all the software, which who knows if it was actually the same version from Subversion as anything else was, right? Then they would package it and publish it, and that produced like 1,000 zip files that they were all stored in Nexus, so that was fine. But then the deployment engineers had to run to 4 or more different environments in Jenkins servers, independently download and stage those zip files, and then go call some kind of ops guy to actually run a bunch of commands to try to install it on the various Red Hat servers throughout the fleet, right? And that could be development, test, and prod. Oh, by the way, they run in multiple data centers, so some of the apps were in one data center and some were in another, right? And the good news is they had attempted to automate it, right? They had Jenkins in place. They had some things that looked like CI in that it was doing kind of continuous builds and things like that, but it was very disparate, right? In the age of maturity, I would call this, the 2-headed mutant tadpole in level of maturity. We hadn't even gotten to a mutant frog yet, right? So they were very much just kind of getting started, but they had the right idea in place. They just hadn't been able to glue it together. So we all sat down and came up with, okay, what are the actual problems here, right? So So what we found out of it is that it was very slow, painful, and human driven, right? So we had delays and confusion throughout this entire process, right? It was like the better part of a day just to take a development build and try to put it into a test environment kind of thing, right? Very heavy on human interaction. So it was very prone to errors and encouraged people, quite frankly, to cut corners. They learned their own secret tricks for how to do this faster. So depending on who was doing what, it got done differently, right? There were often long and complicated, rarely run builds with very fragile scripts, right? So because the builds weren't being done all that often, when they finally did get done, which by the way was at like 8 p.m. every night when the developers finally got done checking in all their code, it would fail hours into the build, right? It took forever. And by then it's like 10 p.m. and the chance of getting any help to fix that was slim to none, right? So always caused problems, right? There was no integrated testing in any way, which is at best you build a package and then people had to manually deploy it anywhere and go run some smoke test against it before you figured out whether it was a good build or not, right? So hours of human effort could be wasted. There was really no confidence in whether that build was any good until a huge amount of effort was expended, right? And then there was a fundamental disconnect between the build and deploy and test groups, right? Again, more confusion and delays. To make things even worse, my sidebar of pain here, the Jenkins environments were very hard to maintain. Most of the servers were very, very out of date, which means it was difficult to use modern plugins. There were lots of security vulnerabilities in the system. It was just very hard to keep up to date. The fact that a lot of them were disconnected from the internet just kind of exacerbated it and made them very hard to update and bring forward. Huge commitment to this old golden Jenkins server that barely worked, right? Which meant, and frankly, there was just no good way to test changes to the Jenkins environment without breaking literally everything. There was no test environment. There was no way to change even major jobs without breaking things. So what was our approach? What was our solution, right? The key factors to success of where we went from there was what I would call pipeline design and DevOps engineering were the two major key factors. So I'll explain a little bit about what we meant by that, right? So a big part of any kind of DevOps and CI/CD automation effort really comes down to what I will call the delivery pipeline design. And, on screen, we have a very, what I would call typical kind of classic pipeline design now for kind of modern good practices, right? So, and on the left, you have the kind of continuous integration block, and on the right, you have what I'll call the continuous delivery block. And during continuous integration, right, we're concerned with compiling the software, running all the unit tests, running static analysis and quality analysis, packaging up the successful artifacts and publishing such that they can be used downstream, right? And some important parts of that is every commit triggers a build, right? And that was the first thing we went to put in place. The second side of that, then, continuous delivery, what we mean by that is now you want to deploy it somewhere, right? You've got a successful CI-driven build. You want to deploy it somewhere, right? So that means provisioning and configuring some kind of set of machines to be able to put this into, right? You need to install the software. Once it's installed, you configure your newly installed custom-built software. And then finally, you need some kind of validation to verify that that actually worked, right? Because your next step then is to do what you really want to do, which is test it, right? And testing often has a lot of levels. It could be smoke testing, API level testing, UI testing, functional testing, and let's face it, even manual testing, right? So in most continuous programs I've seen, you never completely get away from manual testing, right? Now, in our situation, we were using a tool chain where Jenkins was the center trigger for everything. We were actually using Ansible for custom deployment, right? So we got away from a lot of the custom shell scripting. And in this particular case, we were using Gatling for testing across multiple levels. And while Gatling itself technically is a performance tool, the teams were able to use it to basically automate a lot of their API level and even UI level testing. So they kind of combined test suites, right? But the key things were every commit triggers a build, every build triggers a deployment, assuming it passes, and then successful tests enable promotion, right? Because the right-hand side is kind of the important thing. You start in dev, and assuming everything works, then you repeat the delivery cycle into test, and you keep stepping upwards until you get to something that looks like prod. Right, but we do this consistently, right? So what were some of these kind of successful CI/CD patterns? First, build every branch continuously, and this is something we put in place, right? Every feature CI build gets triggered, right? So every feature branch, any change the developers make automatically trigger a build, so we know very quickly whether their independent features are actually breaking things, right? And then the other thing we had is release tracked builds. So the main development branch where people are merging these features into, targeting a next release, we had CI builds that would build that too. So as soon as any kind of merge happened onto that branch, we would immediately assess it and determine whether it was any good, right? So that's pattern number one. Second, unit tests run as part of every CI build, right? If you were not doing unit tests as part of your CI builds, you're doing it wrong. Go figure out how to tie your tests into it, right? Similarly, SonarQube we use for static analysis. And again, it's run as part of every CI build. It's not run 2 days before you release the software, right? We assess the software as early as possible, find any kind of quality and type defects, and try to feed that back to the developers and assess them as soon as possible. We were also running Fortify security scans, right? And Fortify is significantly more expensive and takes a lot longer to run than something like Sonar. So we would kind of fork that off, and we would run security scans on typically the release branches and nightly, because that's really all the computation we could afford. Ideally, we could run it on different branches sooner, but in our case, we simply didn't have the capacity, so it actually worked fairly well for us, right? Also, numbered releases get pushed to Nexus, so every time we did a real release, we would push it to some kind of deployment repository so that could be deployed somewhere, right? We avoided what are referred to as snapshot builds, and anybody who's done anything with Maven or really even Gradle probably familiar with the concept of snapshot, which is just the latest and greatest, right? Well, I can't deploy the latest and greatest because I never know what it's going to be, right? So we focused on having like real release numbers to be able to do that. The release builds themselves get deployed to a dev environment automatically as part of the CI/CD chain, right? So as soon as a dev build passes its unit tests in Sonar and is deemed of quality, it immediately goes into some CI development environment. So we can immediately deploy it, make sure it deploys, and then trigger tests beyond it, right? Then after we do those cycles, all the promote jobs that take it from dev and go to test or prod are all driven with the exact same automation, right? So we use the exact same Ansible code to deploy it in other environments. That way we have confidence that deployment can actually succeed, right? Just out of curiosity, in Jenkins, for anybody who cares, most of the pipelines we built for this particular project were all done using what I would call traditional job change, which is using the user interface of Jenkins to construct job chains. There are newer efforts that we're putting in place now that do more of what you really call pipeline as code, where you're using the Jenkins scripts themselves and they get checked into version control, and Jenkins is much better and has new kind of internal architecture that can manage those better, but that's a totally different story. So where are we? Well, 18 months later, in many cases, we have realized what I will call CI/CD, right? So what does that look like? Well, we're using GitHub now. I'll talk a little bit about that later instead of Subversion, which enables some things but isn't critical. We now have a scalable set of Jenkins servers that we can create new workers and new agents to do more capacity when we need it, right? And the Jenkins server is responsible for running all the JUnit, running all SonarQube, doing all the compilation, unit testing, packaging, publishing, and then it actually triggers all the deployment downstream with Ansible, right? And then Ansible is used to deploy into dev, test, prod, etc. in whatever data center we care about, right? So single point of service now, right? Another minor factor we did that improved a lot of things was using RPMs to install things because we were running in a Red Hat environment instead of zip files. And this allows for a much cleaner single point installation, uninstallation of at least the application assets for what we're doing, right? And that actually streamlined a lot of things and made a lot of stuff simpler for us just because it's effectively a one-step command to install a particular application, right? The only real human interaction in any of this is really promoting from environment to environment. It was push-button-based promote, from dev to test or test to prod. And that was all handled seamlessly. Now, of course, while they were in this environment, there's still a lot of manual testing going on, but I mentioned earlier we were able to use Gatling to basically automate a lot of the testing. So by the time it goes to any of these environments, it's had a pretty heavy set of automated testing. In the maturity level, we've kind of achieved the hipster toddler level here, which is we're doing a lot of really cool stuff. By all means, there's still room for improvement, but we're getting there. And this was for a lot of the newer generation applications that were being built from the ground up on our project, very successful and was working quite well. So we're mostly on target at this point, right? We got very close to what we actually cared about. A little bit more of a sad reality is for some of the more legacy applications that have a lot more baggage associated with it, we weren't able to kind of fully achieve that, if you will. You know, we still had the same Jenkins server that was doing all the CI builds, so we put true CI in place, right? Compiling, unit testing, sonar. For all the release management stuff, we were able to do packaging and publishing, and then we were able to trigger at least the staging of the assets, which effectively pushed them into Nexus. And then the way the deployment worked for these is they couldn't automatically fetch assets, so we would actually push the assets onto the various servers. But I can now do that from a central point, right? So I use Jenkins now to push the assets into, you know, the test and prod and the dev environments in multiple data centers. And I was able to eliminate, you notice there's like 3 guys running around on this sheet instead of the 6 or 10 guys running around on the other diagram I had earlier, right? Still wasn't able to get rid of this crazy build request form, but we streamlined it a lot, so there's really very little information of any use that goes on it anymore. It's really tied up into the build. So, you know, we didn't even achieve kind of hipster toddler at this point, we'll call it drooling baby, but took a lot of the problems out of it. You know, what it really came down to is even in the legacy world where we couldn't achieve this kind of perfect CI/CD type stuff, we got a lot of benefit, right? We were able to follow a full CI process and get all the way to what I would call the disconnected command line scripted deployment. So full CI and even staging, at least to get the assets near the boxes where they needed to be, and then ops guys would still have to go and run some command line scripts to take those assets and fully push them out. But it was much more streamlined and we removed a lot of the human effort. So again, major improvements, right? We were able to tie the CI processes into what I would call a single break the build chain, in which anything along the line that failed quality would break the build and effectively invalidate it. That's what you want, right? So we would build with every check-in, compile, test, analyze, do as much as we could, at least with unit testing. So a largely improved view of quality at any given moment. Right? We consolidated all those build and staging jobs into that single server so that somebody didn't have to log into 6 different Jenkins servers just to try to get a build of software to somewhere that needed to be deployed, right? It's the same jobs for CI and release build, very similar pattern. And then automated deployment staging from that server kind of connected to that CI and release building process, right? And of course, the caveat, as I kind of mentioned, was we still needed a set of deployment Jenkins servers in that we kind of still had some Jenkins servers over on the other side that could touch like a production server sort of thing. And that had to do with connectivity between data centers. Eventually that'll go away. But now we're down to 2 Jenkins servers instead of 6 kind of thing. So that was a major improvement. The other improvement we saw was by setting up Jenkins with scalable worker nodes, we could easily add capacity now to onboard more applications and teams as we needed to, instead of having a server that's constantly being crushed, right? All of this stuff really was a stopgap to stem the bleeding as we move forward into a DevOps, more of a DevOps kind of process. And I'll get to that a little bit when I start talking about the DevOps principles of engineering. So one kind of sidebar. In doing this, I'll kind of re-emphasize the importance of modeling your branching strategy over the way that you want to build software, right? Where we started is historically, the development teams would use parallel, monolithic, long-running release branches. You know, I would have release 20 and release 21, and they would all be done in parallel, and we would start them and then start another one. So we had this kind of crazy cascading branch pattern, which, as it turns out, isn't that uncommon, but had a lot of detrimental effects, right? It's these big giant branches that everybody was trying to use. There was, and oh, by the way, they did use a little bit of what they would call feature branching, but what that really meant is they just had one extra branch that everybody would use that they called the quote feature branch to, you know, parallel their release branch. So if you look at my little diagram, this could either be the feature branch pattern or the release branch pattern. They both looked exactly the same. They didn't have any what I would call small feature-based development, right? There was also absolutely no central build until they merged onto a release branch, which means you really had no idea if your software was going to build until you merged it onto the release branch and tried to integrate it, right? So that was painful. They did what they called level up merging, so the changes and bug fixes on release 20 had to periodically be moved up to release 21. And often they would wait a long time to do this. So by the time they got there, release 20 and release 21 were so divergent that merging them together was very painful, right? So these N to N plus one often took multiple days of manual inspection of code to figure out what happened. And the result was they frequently lost or overwrote changes and made a big mess, and ended up with what I would call late discovery quality issues, right? So the result of all of this is they were absolutely terrified of merging, right? They're like, oh, we're going to be down for a week because we're doing a merge. So what do we do? How do we address that? We really put in place something that wasn't radically different than what they were doing, but made it more fine-grained. We did switch to Git, specifically GitHub, which helped a little because Git is just a lot better at merging. But quite frankly, what we ended up changing, you could have done in Subversion as well. But when we switched to Git, we kind of re-emphasized the branching model. And we introduced an emphasized feature, or what we call topic branching, where every single feature, bug fix, or independent change gets its own feature branch. And we enabled the developers to create their own branches and do their own thing, right? So we kind of educated them on actually embracing a version control tool and learning it, right? Then Jenkins had all these CI builds that would trigger automatically for each feature branch, right? So any feature branch they had, we would compile it, run the unit test, and run the sonar analysis so that developers immediately got feedback on whether that what they were doing was compliant or bad, right? So they get to figure that out. And then the second thing we instituted was basically mandating pull requests for feature to release merges. So you had to basically submit a pull request or a merge request, depending on which tool you call, that allowed the project manager or tech lead to then review the code, because you now have a GUI-based system to see all the code changes, right? So this basically gave them an anchor point to do real code reviews, and allowed them to kind of see what the integration looked like, right? And then once that was merged on, the release CI would double check the success of that merge almost immediately, right? So the result of this was that code quality immediately skyrocketed. They had reviewable changes. They almost never had merge failures. They started regularly doing level up merges, and they caught the natural integration problems that are going to exist between two branches on a weekly basis instead of a monthly basis, right? And for that painful thing that hurt them all the time, by doing it more often, it made the pain smaller, and the pain effectively just went away. So it really just emphasizes that your entire development process, when you anchor it in this CI process and you use a good branching model, can help you a lot. Another good piece of success, right? So I talked about DevOps engineering, and what do we mean by that? I outlined in the beginning, but incrementally creating capability, treat everything as code, really means version control everything. DevOps your DevOps, usability is key, and shift assurance activities left. So what do we mean by these? When I talk about incrementally creating capability, we mean you want to start small with whatever high-value automation that you can put in place for biggest benefit, least cost, right? So what that usually means is to automate frequent or error-prone deployment staging. Get it in place to do the things that are done most often or have the biggest problems, right? Get continuous integration in place immediately before trying to attack CD, right? Because you don't want to waste time trying to install a bunch of bad software if you don't even know if it's any good, right? So start on the left side and start moving over. And it's really not that difficult to get something like CI in place. Automate the frequent application deployments before infrastructure. You probably install your application 6 times a week. You probably install or upgrade the Tomcat server twice a year, right? So don't waste your time automating a bunch of Tomcat installations when you can't even install your software, right? You already probably have an environment that has, the basic middleware stuff installed in it, if you're doing many deployments of your app software, automate that first. That's not to say don't automate the stuff underneath it, but you can do the up top stuff first. And then you can kind of do that out of band where the infrastructure deployment can be done independently by other teams who understand the infrastructure better, right? The other thing that you really need to do is control your configuration and property deployment, because the one interesting thing, which is your software gets built and then installed in multiple environments, well, one of the trickiest things is how do you configure it different in each environment? And that becomes a very important thing to try to automate as early as possible, is how do I actually configure it? How do I create config files? How do I create property files, et cetera, to get it correct in those various environments? And that needs to be parameterized as early as you can. It's important while doing this that people look at it with a can-do attitude, right? Some of it's scary. You want to go audit with how can we speed up deployments? How can we make improvements instead of, oh my God, it's too hard to change. We can never do that, right? Start small with oh yeah, we can make little changes without getting completely wrapped around the axle of having this giant boulder of things that need to be changed, right? So take positive approaches, find people who want to look at improving it, and that's what's important. As you do it, it's very important to remove whatever barriers there are to success, right? We want to bring teams together, we want to get people communicating instead of just emailing all the time. DevOps is about bringing teams together to get them to work better together, to get them to deliver software change faster, right? DevOps is all about accelerating your ability to deliver change and value to your customers as quickly as possible, right? And it involves people actually working together. You cannot do this with too many barriers in place, right? You need to give people access to the resources they need, whether they be human beings or machines or whatever. They need it, right? And a lot of times for us, that meant Jenkins, which is getting more people involved in Jenkins and seeing their results and triggering their own builds and diagnosing their own problems meant that you didn't have to send a bunch of emails out to a bunch of different teams trying to diagnose stuff. Second principle was treat everything as code, right? First part of that typically involves using some kind of deployment tool, right? In our case, we were using Ansible, but it allows us to version control what it means to configure an OS, right, an operating system, to configure the middleware and get it installed, to configure our application and get it installed, right? It allowed us to kind of keep that configuration in play, and by the way, replay it in multiple places, right? We can use that as automation. The other important thing about this was it was important for us to version control Jenkins, right? And the systems surrounding Jenkins, the Ansible configuration, the Sonar configuration. I'll talk about more of this in a few minutes, but it really came down to we wanted to be able to replicate our build system and repeat our build system and make changes and introduce changes into our build system, which I'll talk about as the kind of DevOps your DevOps. So it was important for us to version control Jenkins as well and everything around it. When I talk about DevOps your DevOps, and this kind of leads in from the previous one, it really is about, in many cases, automating your Jenkins environments and the creation of them and the replication of them and tracking change and being able to roll change to your DevOps pipeline, to your CI/CD pipelines in a controlled way, just like we do with software, right? We want to easily be able to make changes. We want to be able to replicate those changes. It helps with disaster recovery. God forbid, should I lose my Jenkins server, right? I want to be able to get that back as quickly as possible. And then finally, it allows us, quite frankly, to replicate and test our capability across multiple environments. So if I want to test out some new and fancy stuff in Jenkins, I can do it over here without negatively affecting the development teams who depend on my prod Jenkins server to be working all the time. Right? We actually use Jenkins to self-manage deployments into its own environments, right? So in Jenkins, I have jobs that I can run that will update the software and update the plugins and install new configuration on the Jenkins servers themselves or relaunch new environments. We ended up implementing both a test and a prod Jenkins environment, which I'll show you a picture of in a minute, which were treated. It's exactly like treating similar to would any other production app, right? I have my app, I have a dev environment, I have a test environment, I have a prod environment. Well, we had a test and a dev environment that we could make changes in our Jenkins environment and be able to roll those out without affecting and breaking prod effectively. This is mostly a place to make infrastructure and major changes. We didn't make all changes in test and promote them to prod because it is kind of an online system, so it worked pretty well. What this ended up looking like is we had this kind of red block at the top, which was a sandbox test DevOps environment, which had a full Jenkins server attached to a SonarQube server. It could invoke Ansible. It had its own Nexus server. We pulled out a Git source code. The Git source code tended to be a single point of service. And then we have some target environments on the far right, which allows us to run deployments into kind of sacrificial target server environments, so we could test out, our Ansible provisioning code, our Ansible deployment code, right? And this allows us to effectively test changes. And then as we understand what changes work, we're able to promote them into what we called our DevOps production environment, which looks exactly the same, quite frankly. It just has a lot more target environments where we deploy things, and in many cases, more capacity. Our big prod environment had, I think, 5 worker agent machines attached to Jenkins, where the test one only needed a couple just so that we could prove things work. This allowed us, one of the most powerful things that this did was allow us to do things like Jenkins upgrades to validate that we weren't going to break all of our pipelines before we actually put those into prod. So a very valuable kind of example case of DevOpsing your DevOps. For the actual replication, this is Jenkins technical, but Jenkins has both configuration as well as the jobs it actually runs, and we managed all those through GitHub, and we can merge them across branches to get them from test to prod. The software itself it ran on top of, we configured purely with Ansible, so actually installing Jenkins and installing Maven and all the tools it needs is completely handled by Ansible underneath, so it was very easy for us to move configuration from one place to the other. Similarly, the Sonar and Nexus servers were largely managed through Ansible, so the actual software that got installed was able to move back and forth. That included for Sonar, we were able to do it with rules and plugins and configuration. The Nexus server we really never attacked with replication, just because it's really a data repository. The installation, all done with Ansible, but periodically we would look at merging and rsyncing kind of content and repository content between those. So that was slightly outside of scope. One of the fun success stories that kind of came out of this DevOpsing your DevOps is we recently went through 2 major upgrades of our DevOps environments, of the Jenkins environments. One is we switched from open source Jenkins and moved to a cloud-based Jenkins platform, a commercially supported one, which is a different software installation, more licenses, etc. And the second one is after doing that, we went from a super old 1.x Jenkins up to their kind of latest and greatest long-term support 2.7 Jenkins, right? Because of this test in prod, looking back at my diagram, right, because we were able to do this in our test environment first and go through all the trial and tribulations, which, by the way, was not painless the first time. We messed it up a couple times. By the time we hammered our way through that and rolled it out to production, it effectively became a non-event, to the fact that we had conversation a couple days after the Jenkins upgrade with some of the senior leadership. They're like, oh, by the way, when are you guys upgrading Jenkins? When are you going through this whole massive process? And our answer was simply, we did it 2 days ago. It's done. And the response being, wow, I didn't even notice. And that's what you want, right? That's what production upgrades should look like. It's true of our application software, and as it turns out, it's true for our DevOps environments. We want to be able to upgrade this stuff without anybody ever noticing, because all too often, IT people are only noticed when things go belly up and go crazy. And that, to me, was kind of a tantamount to success. Was you're doing it right when nobody notices what's going on. So, and the key success points, I think, were by automating that configuration of Jenkins with Ansible, it made it very easy to replicate and to test things out with software upgrades. By version controlling all of the jobs, we could replicate them across environments and test out and make sure our jobs still worked with new versions of Jenkins. And that ability to replicate into the test environment meant that I could try it, retry it, repeat it, destroy it until I got it right, such that it was effectively practiced. So when we went into prod, again, non-event. Moving on, usability is key is the next principle of DevOps. And what it really means is that people need to understand what the system is and how to use it. How do you actually go through things, right? So one of the things in DevOps is by using scripting systems like Ansible or Chef or Puppet, the deployments and the quote code that you write for this becomes the documentation, right? It's codified mechanisms of how to do this. And oh, by the way, it's executable, right? So you no longer have these complicated, 20-page Word document runbooks for a deployment, right? Because it's all written down in Ansible. If you need to know how it works, go look at the Ansible. If you need to change it, go fix it. You can branch it, you can modify it. So that was kind of the first key point about usability. Second key point is that Jenkins is an interesting system. It was originally built and created for what I will call build nerds. These are people who were trying to build software and get feedback on whether the software works or not. It really was never designed for what I would call ops nerds, which are people who want to push a button, watch the progression of a deployment, and make sure it succeeds. So the way we address it is having a lot of what I would call self-documented procedures and job links that lead people through Jenkins. So we use HTML navigation within the Jenkins system to be able to lead people where they need to go, run the right jobs, and oh, by the way, remember what the right parameters are to do it. We try to visualize as much as possible the useful stuff, progression of pipelines, red, green status of whether things have completed, and ultimately what the results are, right? So you need to think about the fact that it's not just going to be some super smart Jenkins nerd who's using this system. It's going to be a lot of different people. Right. Third point was everybody should build software the same way. This means that developers and Jenkins should be using the same effective systems and scripts and everything else to build software. Of course, developers are in most cases going to use an IDE and click a bunch of buttons most of the time, but that needs to be tied into the same thing that Jenkins is ultimately going to do. So this means really Maven, Gradle, Sonar, testing instructions, should be a known set of instructions. We tend to document in the READMEs that go with the source code, and we make sure that that's what gets tied into the IDE for how things get built, so that by the time it gets to Jenkins, it's not a completely different process. Everybody can use the same thing. And then finally, have a single central Jenkins for this build, staging, and deployment was a key value for us. I didn't want people hopping to 30 different places to do all this stuff. I wanted them to go to one good place, get it all done, and be able to watch the progression and tie things together. We want to minimize those hoops that they need for a reliable deployment. Next principle really is shifting assurance activities to the left, right? And here the emphasis is really get feedback as soon as you can. You don't want to wait until the day before you ship before you run your security analysis the first day, or worse, let's say even the Sonar quality analysis. You want to do that early, right? Developers need to build, test, analyze, and deploy similar to the way Jenkins is doing it, right? So again, I mentioned Maven and Gradle builds. It builds and drives kind of everything. So they can invoke it just like we do on Jenkins. The Sonar analysis, we want them to be able to run Sonar locally in their machine before it even goes to Jenkins. And then in Jenkins, we're going to run it as soon as possible as well. And we need this to be for all releases, right? Which is the next point, which is not just the release branches, the official branches, but the feature branches ahead of time, right? And then finally, back to the developers thing to finish that part up, is use Ansible. Like we're deploying it with Ansible, you guys should do it too, right? So make sure that's tied into the developers so that they're not just push button deploying everything, but they actually get to experience some of what's going on. As this progresses, you want to deploy and test whatever new release candidates you have using Ansible, right? Because the sooner you do that, into a dev environment, closer to the left again, the sooner you'll know whether it's going to succeed or not. We definitely use the GitHub-based pull request to get feedback earlier. It used to be code reviews didn't happen until 3 weeks before a release, or a week before a release, or a day before a release, and there was no real good mechanism to ensure that they happen consistently. By forcing people to use these pull requests, it effectively forced them to go through a code review before they could get merged, so nobody ever saw their code until it got merged. And oh, by the way, when they did the code review, they had a small cohesive set of code that was about one set of features, and that's definitely a success pattern. The smaller you have to review, the easier it is to understand whether it's the right thing or not. And then finally, frequent merges of small changes into a release are a lot easier to deal with than these big, giant, late lifecycle merges kind of thing. So again, early merges are better merges. So what's the summary? What were the kind of key takeaways? Some of the key features in these patterns that we introduced that provided value was the integrated Jenkins servers for that single point of reference, being able to use master, slave, worker kind of scalability to get build capacity when we needed, having a test prod Jenkins to be able to keep a stable Jenkins environment at all times, full continuous integration, doing feature and release CI builds with that compiled test Sonar and packaging, tying that to continuous delivery with push button deployments to get, basically push button into the next environment, even if you weren't just going to automatically let it go through the whole process. Ansible automation instead of these hand-built scripts. We got out of the business of trying to maintain a deployment framework. Instead, we're in the business of invoking a deployment framework, which is more in line with what you want. And then finally, Jenkins orchestrates everything. No humans, right? I don't need humans. Get them out of the way. I don't want people getting on machines and doing command line. And, I mentioned the two situations, kind of the new generation versus the legacy stuff. And certainly with the newer generation, we were able to hit almost all of these key features, provide a lot of value. But even in the non-perfect world, right, the legacy systems that had so much more baggage, it allowed us to kind of gain some benefit, right? It didn't have to be perfect. It just had to be better. So what was the value? In the end, what kind of value did we really see? Did we really collect any metrics? Not really, but one of the things we noticed when we did look at it is we went from doing kind of a few dozen builds a day slowly and providing only a little bit of feedback to doing literally hundreds of builds today across these many servers. And what that really means is that you're getting a lot more feedback, you're investigating a lot more stuff, you're having these computers pound through your code, run tests, run analysis, providing feedback as soon as possible. That very much increased those feedback cycles, and that was valuable, right? This led to radically reducing the quality problems due to these bad merges and code that doesn't work between versions. All of this stuff was happening earlier that I don't have any metrics about how the quality went up, but we know that it did, and it just became culturally massively more aware that, oh, the code's actually better. We're not fighting with ourselves as much. Some of the perceived impact and benefit across the teams were, with feature branching, this isolation and reviewability of feature-based code changes really helped. There were fewer merge issues, easier to review the quality for code review, and just overall improved quality. This rapid feedback I keep saying in the evolution of code by doing these hundreds of builds per day, by doing that CI of all of the features, it immediately shows results, even for those isolated feature branches that maybe only a developer or two developers are working on. The CI for the releases identified those merge issues quickly. Like as soon as somebody merged, if the release branch failed, you knew about it, right? And people were very cognizant of going to fix that immediately. And the scalable capacity allows us to kind of improve the turnaround time so that people aren't queued up forever waiting for a build. As it turns out, they're using it so much more, we still have this problem, right? So we still have scaling things to do. It's not perfect, but it's so much better, right? And that's what we want. I did find that the unified build process for scripts and applications, by having that single point to build CI on a single server, I know that the official release builds are going to look just like the ones I did for quality testing and release branches and doing the CI builds. So again, tangible improvement in that I know it's going to be the same and I don't have weird failures. Then finally, the testability for DevOps upgrades allowed us to do kind of seamless, low-risk evolution of our DevOps tools without impacting the ultimate delivery of the fact that developers are waiting for their code. They want to be plugged in places. And those were, I believe, some of the key values. At that point, that's it as far as material-wise. For anybody who's still here, if you guys want to ask some questions, I'd be more than happy to take some questions. And if not, thank you very much. Any thoughts? Anybody still awake?
Hey, Rich.
Hey.
So I guess the question I had, and something I was thinking about through it, is it sounds like there are a lot of changes that that have to be made from an organizational standpoint, and in terms of the challenges that can you talk a little bit about some of that in terms of personnel and people's resistance to change, if any?
Yeah, the biggest barrier, and this is both generically and specific, that I always find is that the more silos of different teams and separate responsibilities you have, the more painful it is. So if you got a dev team and a QA team and a deployment team and an operations team and a build team, you got 5 or 6 different teams. And even worse, you may be in a contracting situation where you've got contractual barriers and metrics in place that they're all judged on different things, right? And you have a lot of throwing things over the fence. That's by far the biggest generic barrier that I can think of. And really the way to address that is forcing people to actually work together. Not just email things back and forth, but the first way kind of through that is to get people to just talk, maybe on the phone, maybe on Skype meetings, maybe on GoToMeeting or whatever. And then if you can get actually physically in place with each other, it starts to break down those barriers so that people realize they're working together. Enabling other teams to do the things they need to do instead of just throwing it over a wall also becomes important. So for example, I often find that the pipeline itself is an anchor point for that. Meaning, by getting people to go to the pipeline, to go to Jenkins, to look at their build, to push a button to do their own build or to push a button to do a deployment, even like developer can go push a build and deploy into a dev environment, right? They start to do some of the same thing that the ops guys do, and it tends to bring them together, and at least they start understanding each other's problems. So that's kind of the meta answer to the problem, which is it really is, as you kind of enumerate, like the farther people are away from each other mentally, the harder it is for them to work together. But I do find, Jenkins can be, things like Jenkins and Ansible or Chef or whatever you're using can be the great unifier, which is it's a common language, it's a common platform that everybody starts using to try to get their work done. And it tends to, encourage at least talking about the same things or speaking the same language.
So basically getting it to kind of play with it, so to speak, and let them see the impact that they're having.
Yeah, and the more you can enable people to solve their own problems and not have to wait for another team to do it, the more likely it is you can break down some of those barriers. Of course, it's different for every organization, but conceptually, that's usually where I try to push.
Makes sense. Thank you.
Yep. Anything else? Well, very good. We're pushing right up on 1 o'clock, so we're kind of on time. I think I actually kind of sort of almost hit 45 minutes. This was originally a 45-minute talk. Probably that I could talk for an extra 2 hours about if I really wanted to. So trying to squeeze it into 45 minutes is a little challenging. But I appreciate everybody coming by today, especially on short notice. And have a good weekend.